Hello everyone, welcome back to our premium course. Today we continue to discuss about the Flang Beam in Tekla Structural Designer. Open the model, so the slab item. To check the Flang Beam, come back to the structure and click on the review Flang Beam. Now you see the color legend Flang with determined automatically. This beam I select and change to the Flang Beam. The software recognize automatically and calculate the effective width of the Flang Beam. So how we can select and choose the beam design as the Flang Beam or design as the rectangular beam? Come back to the structure. I don't want to show slab because we difficult to select the beam. Click on the beam, but now the slab also select. Escape again. Turn off the slab items. Click on the beam you want to design as the Flang Beam. Scroll down, find the Analysis and Design, Control, and expand all. Take on the Consider Plane. Include plane in Analysis. Check. So this beam will be calculated as the T beam. For the beam, if we use the same method, design, analysis, design, consider plane, so this beam will be considered as the L beam. Now I show you how you can check analysis, design, VIT, analysis and design, control, consider plane, include plane in analysis. Or you can define effective width of plane manually. The same for the L beam and for the T beam, but don't want to use manually to define the width of the plane. So the software will be automatically calculate the effective width of the plane. You can include the opening, yes, via location or opening. Come back, click on review, concrete plane. Check the color legend plane with determined automatically. You see this beam in the grid line H and in the grid line 1. The color is represent the plane with determined automatically, T beam and L beam. Come back to the support document for the plane concrete beam in Tekla Structural Designer. To consider a plane under Analysis and Design Control in the property window, typically plane beams can be either T shape or L shape with a slab on one side of the beam. L shape with a slab in one side of beam. For the T beam, shape with both sides slab on the beam. To consider the Flang Beam, the slab is present. The slab and beam construction monolithically, or it means that the slab and beam casting concrete together. The program automatically validates the slab as the potential candidate for being a beam plane using a number of criteria. The slab can be one or both sides. One side can be a L beam and both sides can be a T beam. The slab must be a reinforced concrete slab. There are slabs on both sides of the beam. They may be of different depth and the dips may vary along the length of beam. The slab must have a top surface consistent with the top surface of the beam. There must be a slab overlap greater than 50 mm or 2 inches, as shown in the following illustrations. You can check the picture. Slab 1, alignment at the top with the beam, and slab 2 is different level. You can check. Slab 2 is not a validated candidate, so indicate the software cannot include the right slab as the Flang Beam. For the left slab can be considered as the L beam. In this section you can check the below picture, the alignment at the top right beam, the right slab with the beam, and the slab overlap. Check the overlap. Is the slab overlap greater than 50? Slab 1 is a validated candidate to act as a flank. The effective width of any valid slab on each side of the beam by effective is calculated, and the flank width result appropriate at the mid-span length point display along with the flank depth. Check for the simple supportive beam. L0 is equal to L span length. For the continuous beam, the L0 may be obtained using the following simplified rule. The continuous beam with a pin and support, so the L0 is equal to 0.85 L. For the fixed support, L0 is equal to 0.7 L. For the internal span or continuous beam, L0 is equal to 0.7L. Check the earth span or internal span. What is the earth span and where is the earth span and where is the internal span? This is the internal span. It is the earth span. The internal span of a continuous beam, the L0 is equal to 0.7L. The L is a span length from support to support, and L0 for the flank beam is equal to 0.7L. You can read more detail in support document. What the software consider the effective flank, effective width, and the slab overlap. You can check with the direction of slab overlap. Thank you for your watching. I hope you enjoyed this tutorial. Thank you.